So, thermonuclear fusion, like the sun does it, is pretty impractical as you'd have to have huge temperatures that would pretty much melt any containment device that tried to hold it. Now, a way around this is magnetic confinement fusion. Now, imagine a cylinder, and then imagine it wrapped around itself to create a kind of torus. Now, what magnetic confinement fusion does is it uses magnetic fields to create plasma and then contain this plasma using magnetic fields so it doesn't come into contact with any object, which it would destroy if it had. So this torus that we have, it is confined by two magnetic fields. First, a toroidal magnetic field, which is created by a bunch of magnets around the circumference of the torus. Now these magnets, they confine the plasma into a tiny little unit, and then the palladial magnetic field turns on and off and it goes around the circumference of the torus. And what this does is it accelerates the plasma and keeps it going in a circle. And it also energizes the plasma so it can get to a state of matter where its electrons are stripped off. The plasma is further accelerated by the injection of high energy neutral particles, which would of course translate their energy to the plasma and further increase the acceleration of the plasma in the direction that the angular momentum is already going. So as this angular momentum increases, it gets to the point where it can overcome the magnetic repulsion between the deuterium and tritium, as deuterium-tritium fusion is the most common type of fusion, and the deuterium plasma and the tritium plasma fuse together. Now, thus far, we have not created any energy levels that are greater than the energy levels inputted, but this is a pretty promising field of fusion as you have magnetic fields which are useful for containing the plasma and utilizing the movement of the plasma.